Welcome back to part 2 of our live training session here with our K24 swapped Civic Si. In this training module, we're going to turn our attention into setting up all of our 2-dimensional and 3-dimensional tables found within our Emtron programming. We have a lot to cover. Let's jump in so we can check this out. Welcome back to our live training session here with our K24 swapped Civic Si. Now in this tutorial, we're going to continue on with our base map creation process that we started with in the last tutorial. We're going to be moving into dialing in our 2-dimensional and 3-dimensional tables, also some programming strategies, how we can work with our fuel and spark timing and variable cam and combine them together with our VTEC function, which is a low-high cam function within our Honda engine. So we have a lot of things to discuss here. Now the very first thing I want to do is take a look at doing a sensor overview check. So making sure that everything we programmed in that last tutorial is going to be accurate. Things like our flex fuel control or our basic sensors like our manifold pressure, fuel pressure, air temp, coolant temp. We can see some of that from our screen right here on our main dash on the right hand side. However, if we toggle F3, let me go ahead and do that right now, it's going to bring up our master runtime value list. And here we can really take a look at things and see every single detail that we could otherwise miss if we're only looking at our data here or below in our screen. So let's jump in here to our very first tab under engine sensors. We can find the manifold pressure showing 98 kPa, which is going to be reflective of my elevation that I'm at here for my shop. So I'm approximately sea level, slightly above sea level. And we're finding here that the manifold pressure, 98 kPa, is pretty accurate. Now, if we're looking at our let's look at our barrel pressure. We should find that right here, 97.27 kPa. They're very, very close to each other, which means that we have an accurately calibrated map sensor reading. So we want to make sure both of these are correct, and the barrel pressure should always be correct because it's an onboard barrel pressure sensor. We're utilizing map over barrel in terms of an efficiency calculation, as we'll find here in the axis to our fuel table. So it's very important that both are calibrated right, and they are, so that looks good. So we know that the map pressure sensor has been calibrated correctly. If we look down our list a little bit further, we see engine temperature, inlet air temperature, 12 degrees Celsius and approximately 9 degrees Celsius here, depending on what we're looking at. There's a little bit of spread in temperature there, a couple degrees. That's not going to be uncommon to have them slightly different from each other, but that is going to be reflective of the temperature I'm finding in my garage right now. So that looks good. Let's go down here a little bit further. We are finding the supply voltage is going to be here 2.38 volts. I do have it on a battery charger right now, just so as I'm filming it doesn't go low on the battery and create problems for us, but that battery voltage is going to be good. Looking at our throttle position, we did calibrate that, so I'm off the throttle right now at 0, coming on the throttle. Now we're 100%, and we see that that has been tracking to that correct linear scale, so that is very important. Things like idle control, overrun fuel cut, transient fueling, all rely on having an accurately calibrated throttle position sensor, so that looks good. If we keep moving on here, we see that the lambda 1 is showing 1.2 lambda, which is full lean, which is what it should read because we have no combustion right now, so that looks good. Let's keep moving on here. Fuel pressure is showing here 194 kPa. The fuel pump has primed the system already a couple minutes ago before I started to film, so we're seeing that the fuel pressure is going to gradually start to taper down and dissipate because the check valve is slowly allowing that pressure to bleed off. So when I prime the fuel pump, keying off, keying on again, we should see that that goes anywhere between 300 to 400 kPa. I don't know the exact base pressure yet until we get it running. All right, let's move into our next screen here. Engine data calculated. Looking through here, nothing is going to be super important in terms of looking at the inputs that we've actually assigned and calibrated. Let's move to vehicle sensors. We should find here, yeah, nothing in here is actually relevant because we don't have any speed sensors coming in. Triggers and limits, nothing in here will be reading or doing anything because the engine is off. We have key on engine off right now. Fuel, we can find what's going on with the fueling calculations or any kind of anything register or reading in terms of a percent adjustment against our main pulse width, any of our injector calculations going on here. We can see all of that through this table. So nothing right now is going to be relevant that we need to worry about. Fuel 2 though, however, this is going to be something we do need to take a look at. We can see the ethanol sensor, which we've set up on our digital input 2. We can see that that's showing the ethanol content of approximately 19.7%, and the ethanol temp is 25 degrees Celsius. So looking at this, I don't know if that degree Celsius here is accurate or not.
I'm not worried about fuel temperature, but I am worried about the ethanol content. And that seems about accurate because I've been using this car for filming on a variety of different standalone systems, doing flex fuel on each system, and I probably have a little bit of cross mixing between petrol fuel and the ethanol that's left as residual in the tank. So you should see, if you're going to be tuning on normal petrol fuel here in the United States, 8 to 10%. Worldwide, you might find you have the ethanol-free petrol fuel. So it might be 0% ethanol content. Really depends on your location and what type of fuel blend you have already. But in this case, roughly 19% seems about right. 19-20% seems right for having a little bit of cross mix. We do see fuel pressure, priming status on, fuel pressure sensor. Looking here, fuel pressure secondary correction status, that's showing disabled. Sequential port on. We do have sequential injection. Speed density is our fuel model. So that looks good. Looking at our lambda, in here, nothing is really relevant at the moment because the engine's not running. Under the ignition, nothing in here is going to be relevant. Knock sensor, we can't tell anything yet until we get the engine running. Idle boost, again, nothing we can do right now with any of this functionality. So looking here, we have a lot of different statuses, a lot of different channel windows we can take a look at right now. Nothing here is going to be super relevant. We do see EFI relay control status is on because the ignition key is on. See switch status, ignition switch is on. Those are basic functions that always need to be implemented on an Emtron to make it run on any engine. So we see all that's functional. I think for right now, we're good. I wanted to check those basic inputs and they look like they're all calibrated right. Let's click close. So now we're going to jump into taking a look at setting up our tables. We're first going to start off here under fuel and work our way across under any of the other drop-down menus here they're going to apply.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.